Welcome to Research Rundown. Today, we're diving into a fascinating study on the potential of large language models, LLMs, to revolutionize algorithm design. Our experts are here to dissect the findings, debate the implications, and explore what this means for the future of computational problem-solving. Joining me in the discussion are two renowned experts with differing perspectives on the matter. A leading researcher in artificial intelligence, is known for her enthusiasm towards the possibilities offered by LLMs. She believes that these models can tap into human ingenuity and design novel algorithms that surpass those created by humans. On the other hand, we have Professor, a seasoned analyst with a skeptical eye on emerging technologies. He's concerned about the potential pitfalls of relying on LLM-designed algorithms and is questioning their long-term viability. Today, they'll engage in a lively debate to shed light on the strengths and limitations of this research. Let's dive into the discussion and explore the implications of large language models in algorithm design.
I'm thrilled to share my analysis of this groundbreaking paper on the potential of large language models, LLMs, in designing novel algorithms that can efficiently solve complex computational problems. The authors have made a significant contribution to the field, and I'm excited to highlight some key findings. Firstly, let's talk about the impressive results obtained by the LLMs in generating efficient C implementations of graph analysis routines. This research demonstrates that LLMs can outperform human-designed algorithms on certain tasks, which is a remarkable achievement. The evidence presented in the paper shows that the performance of LLM-generated code in C is superior to existing benchmarks, particularly when using Claude Sonnet 4 Extended. Now, what's striking about this study is its systematic evaluation of cutting-edge LLMs in producing high-performance C implementations for graph algorithms. This fills a critical gap in existing research and provides valuable insights into the capabilities of LLMs in algorithm design. The authors achieved this by comparing the performance of various LLMs on a range of tasks, which allowed them to identify areas where these models excel. The results also demonstrate that LLMs can be used as a tool for performance-critical systems to generate efficient graph algorithms. This has significant implications for fields such as data analysis, machine learning, and scientific computing, where the ability to optimize complex computations is crucial. The authors' work shows that by leveraging LLMs, we can create more efficient and effective algorithms that can tackle challenging problems in these areas. In conclusion, this paper presents a compelling case for the potential of LLMs in algorithm engineering. By harnessing the power of these models, we may unlock new possibilities for solving complex computational problems, leading to breakthroughs in various fields. The authors' research sets a new direction for algorithm design and optimization, and I'm excited to see how this work will inspire future innovations in the field. As we continue to explore the capabilities of LLMs, it's clear that their potential is vast, and I firmly believe that this paper marks an important milestone in the development of AI-assisted algorithm engineering.
Fascinating perspective from Dr. Now let's hear Professor Marcus W.'s analysis of this research.
The authors of this paper make a rather bold claim that large language models, LLMs, can design novel algorithms that outperform human-designed ones on certain tasks. While I appreciate the ambition, I must express some measured skepticism about the feasibility of such claims. Firstly, I'm concerned that the authors might be overestimating the capabilities of LLMs in generating novel and efficient graph analysis routines. The generated code might rely heavily on pre-existing techniques and optimizations, rather than introducing genuinely new ideas. This would mean that the purported breakthrough is not as groundbreaking as claimed. I'd like to see more concrete evidence of how these LLM-generated algorithms diverge from existing ones. Furthermore, this research lacks empirical results to support its claims. The author's statement is based on anticipation rather than actual demonstrations of improved performance or new techniques. Where are the actual improvements or novel algorithmic innovations presented in the paper? I'd expect to see some concrete metrics or benchmarks that illustrate the superiority of these LLM-generated algorithms. Moreover, there's a notable lack of context in this research. What specific LLMs and algorithmic domains are being referred to? Are there any prior studies that demonstrate the effectiveness of LLMs in algorithm design? The paper fails to provide sufficient background information or references to establish the novelty and relevance of their findings. This omission makes it challenging to assess the significance of their claims. In light of these concerns, I'd like to reiterate my initial skepticism about the transformative potential of contemporary LLMs in inventing novel algorithmic technologies. While the idea is intriguing, more rigorous research is needed to substantiate such grandiose claims. Specifically, I would require empirical evidence that demonstrates a significant improvement over state-of-the-art algorithms on relevant benchmark tasks. Furthermore, I'd expect the authors to provide concrete examples of novel techniques or ideas generated by LLMs that haven't been explored before. Only then can I consider their research convincing and worthy of further exploration in the field of algorithm engineering.
And now, as we wrap up today's research rundown on the potential of large language models to design novel algorithms, let's take a moment to reflect on the lively debate between Dr. enthusiastically argued that LLMs have tremendous potential in solving complex computational problems. Professor expressed concerns about the research methodology and evidence presented. Both perspectives bring valuable insights to the table, and it's this kind of nuanced discussion that often accompanies groundbreaking research. In fact, cutting-edge research is rarely a straightforward affair, but rather a dynamic interplay between different viewpoints and methodologies. Today's debate serves as a prime example of how critical thinking and skepticism can drive our understanding forward. Before we sign off, I want to thank you for tuning in to this episode of Research Rundown. We appreciate your engagement with the topic and look forward to continuing the conversation on future episodes. Thank you again for listening.